All right, in this video, we're going to go over the Algebra 1 Honors Module 3 Study Guide for 2024. The study guide is 4 pages, so hopefully you have all 4 pages with you. All right, question number 1. The temperature of the water in a lake is changing according to the equation C is equal to negative 0.3 T plus 6. So this negative 0.3 is our slope, and we can rewrite that as negative 3 over 10. Our y-intercept for this equation is a positive 6. So our y-intercept is, if that is equal to 6, we're going to go over here to our y-axis, or here our c-axis, because that is labeled C, or our temperature. And we're going to go to 6. Now, to find our other point, some of you may know and remember from last year from your previous math classes that you can go down 3, 1, 2, 3, and over 10. But what we learned this year is that we can also evaluate this function given an input, or x value, to find our y value. So we were already given our 0, if x is equal to 0, our y was equal to 6. But let's pick another x value that'll give us a whole number for a y value. So your clue here that's going to give us a whole number would be to multiply or choose an x value that is equal to the denominator. So when I choose my x value of 10 and I plug that in, see negative 3/10 times 10, because that's going to represent my t, or x value, because it's on the x-axis, plus 6. When I do that, I get the y value of 3. So I can plot my other point here. Now I have 2 points. Now I can connect the dots. Question number 2, which of the following statements is true about the function f of x is equal to negative 3/2 x plus 3? This negative 3/2 is our slope. So we are looking for a negative slope. Well, if I have to match that to graph A or graph B, which graph has a negative slope? Graph B does. So we can select that one first. Then it's asking us about the domain and range of the function. Well, if you're looking at these two graphs, both of these graphs have lines that have arrows, meaning they continue on forever. So because of the arrows, that means that all of our possible x values or domain would be all real numbers. And also our range would also be all real numbers, because that line is going to continue on forever. So it's both true for our x and our y values. Next is the rate of change of the graph of the function. Well, we already identified that first thing. Our rate of change, or our slope, is the negative 3/2. That's why it matches graph B. So make sure when you're taking this question on the test, when you're answering this question on the test, that you have 3 answer choices, because if you're missing one, then you will get the question wrong. All right, suppose that the relationship between price and quantity of widgets sold is linear. So on your paper it said 4,000 and 2,500. I changed that to be 400 and 250 so that we could actually graph it on the graph that's provided to you. So given the real world situation, graph the function. So if the price is $10 for 400 widgets, then we would go to 10 and we would go to 400. If the price is $15, so 15 would be between 10 and 20. We sell 250 widgets, so that's about right here. Yes, I know the line's already there. Pretend that we're just drawing that line now. Then we connect the dots, and when we connect the dots, we do not extend that line on forever, because, and this is a real-world application of a linear function, and can I sell negative widgets? If I cannot sell negative widgets, then that line should not extend to a negative price per widget. Also, the graph must have definitive endpoints and not arrows, because I cannot have a negative number of widgets and I cannot have a negative price per widget. So just make sure that when you're looking to identify your graph to the situation, that your graph does not have arrows on your line. Question number 4, the following real-world situation can be modeled with a linear function. So here we have an icicle, and it is hanging from a roof in Minnesota. It's pretty cold up there, and it's melting on a warm, sunny winter day. At the beginning of the day, the icicle was 8 inches tall. That 8 inches is telling us our initial value, or our y-intercept, which is 8. So right now, this is the only graph, actually, that has the correct y-intercept. Okay? Throughout the day, the popsicle was melting 2 inches per hour, so we're looking for a slope of -2. So if we go down 1, 2, we go over 1, 1, 2, over 1. This does include, and it does have a slope of -2. So graph K is still continuing to match. At a certain number of hours, there was no icicle left. Well, after 4 hours, there was no icicle left. So now we have to complete the following sentences. The graph of the linear function that models the given situation is graph K. That one's pretty easy. The domain of the function in the context. Now, domain talks about our x values. So we're looking at the x values from when it started to when it ended. And because we already know we're talking about graph K, we are looking for when our x values, or t, time, is between 0 and 4. Well, the only one that is between 0 and 4 for t is the letter P. Now the range of the function in the context. So now range is talking about our y-axis, or in this case, our height. So what is our height? Well, again, we're going to talk about 8. So we're looking at this row when we're talking about range, and it goes from 0 to 8. Well, the only one that has height, h, from 0 to 8 is option S. So we select S. So the first part when we're answering this question is to make sure you match the correct graph. Once you match the correct graph, then you're going to match it to the domain and the range of the function. Right, question number 5. At a coffee shop, customers must pay to play video games. Fees are displayed below. So they are giving us increments of 2 hours. However, we don't know the initial value. That's not provided to us in the table. So let's go ahead and first calculate our rate of change, or slope. So at 1 hour, it's $8.50. At 3 hours, which is going to be our x2, we have $13. So what we're going to do is we're going to use our slope formula to calculate our rate of change. So 13 minus 8.5 divided by 3 minus 1. When I put that all into my Desmos for Fast Calculator, I get 2.25. So that means that my slope is 2.25. But I still don't know my initial value. And in order to graph the function, I have to know the initial value. So since I don't know it, I have to find it. Well, if I know that 1 hour is equal to $8.50, can I find 0 hours by subtracting $2.25? So we're going to subtract 2.25, the slope, from $8.50. And that means that our initial value, or our initial cost of playing the video games at the coffee shop, is $6.25. So here we have 6.25. And now we can use that to graph with our slope. And our slope is 2.25. So at 1 hour, we can just look at our points, 1 and 8.5. We're going to look at our next point, 3 and 13. So right up here. And then 5 and 1750 is all the way up here. Then we connect the points. And you'll notice that this line stops here because we can't have negative time. It continues on forever here. So our line should go from, or our graph should go from 6.25 and continue on, because you can continue playing video games for an unlimited number of hours. Then we should have an arrow on this side. All right. Question number 6, given the following, 0 degrees Celsius is 32 degrees Fahrenheit. So that is really what they're giving us there is an ordered pair. So because our graph is Celsius and Fahrenheit, so 0 is our X, 32 is our Y. So we're going to plot that point at 0, 32. When the Celsius temperature is 100 degrees, the corresponding Fahrenheit temperature is 212. That one's a little bit more difficult to graph on this graph, so we're going to go ahead and go to the lowest temperature recorded in Florida is negative 19 degrees. So again, we have another ordered pair, negative 19 and negative 2. So negative 19 is our X, negative 2 is our Y. It should be right around here. The highest temperature recorded is 43 and 109. So 43, 109 is about here. Now we can connect our dots. And here, because we are talking about, again, a real life situation, and we are talking about Florida, this line or linear function has definite endpoints. There should not be arrows on our line or in our graph. If your graph has arrows indicating that it's continuing on forever, that would not be the correct graph. Question number 7. Mr. Johnson's class is conducting an experiment. The class monitors the interaction between two variables, the number of minutes since the beginning of the experiment and the temperature of the solution for 10 minutes. So the results are modeled by the function. None of this is important to you. You don't care about this. What you care about is what is the average rate of change of the temperature in degrees Fahrenheit per minute from 7 minutes. So we're going to go here and look at 7 minutes to minute 9. So we're going to look at 9 minutes. So we're looking at the points. So at 7 minutes, it was 30. At 9 minutes, it was 40. So now we're going to calculate the average rate of change between those 2 points. So we would do 40 minus 30 divided by 9 minus 7. Well, that simplifies to be 10 over 2, which is equal to 5. So our average rate of change is 5. It's that simple. All right, Michaela studies the rate of change for growth in a business that uses the internet in the metropolitan area. I already accidentally left this calculator here. So clearly what we're going to be doing is calculating, again, our average rate of change or our slope, because it says what is the average rate of change in the number of businesses per year. So we're going to go with our highest, 5, to our lowest, 1, 5 minus 1, 5145, so 5,145 minus 1025, and find our slope, 4120 over 4, which simplifies to 1,030. So that is the average rate of change for the number of businesses per year. Question number 9. A caterer uses the table to help customers estimate how much it costs to provide and serve food at their events. The table shows a catering cost for determined numbers of people. So for every person added, the total cost increases by what money? How much money? Well, all we have to do, again, is calculate the slope or the rate of change. So we're going to select 10 and 182, and we're going to select 5 and 125.5. You can select any numbers you want, just as long as you're consistent. So if you select this row, select another from the same row. You don't automatically have to pick the first and last or the first and second. You can choose which ordered pairs you want to select unless they tell you which ones. So when I do 182 minus 125.5 divided by 10 minus 5, I get 56.5 divided by 5, which is 11.3. That means they are charging $11.30 per person is what the caterer is charging to serve their guests. Jason invests $6,500 in a savings account that earns a simple interest at a rate of 2% per year. So we're going to use our simple interest formula that is provided to you on your reference page. And the reason why I did 2 over 100 is because that converts that percentage to a decimal for me. And since I have the Desmos calculator, it'll be easier to do it that way. So I get 7,150 once I plug that all in. And then finally, Christian invests $5,000 into a